Previously, we introduced how to construct a convolutional neural network. Let's take a look at some practical convolutional neural network architectures in the modern era. We will start with the first published convolutional neural networks, the LeNet. So LeNet was an idea proposed in 1990s. So why would people care about using convolutional neural networks in 1990s? Well, essentially at that time, AT&T had a project to recognize handwritten digits for postal codes on letters and the dollar amounts on the checks. So the first convolutional neural networks was proposed by researchers at AT&T Bell Lab, Yan LeCun and his colleague. So the model is called LeNet, and it was widely adopted by the banks back in 1990s to recognize the digits for processing deposits and checks in the ATM machines. So more interestingly, some ATM machines still are running the codes until now. So LeNet was trained on the MNIST dataset that we introduced in the computer vision dataset sections. It achieved outstanding results at the time in 1990s, which gave researchers the first compelling evidence that it was possible to train convolutional neural networks by backpropagation. So here is a demo of LeNet. As we can see, the digits scanning through the networks outputting its estimates of what it thinks that the digit would be. So furthermore, we can see on the left-hand side the activation of the various layers. So here in the first layers, after the convolution, we pretty much get the edge detectors down. So we get the horizontal and vertical edges, or things that enhance construct things, or that reverse construct, and so on. So the next layer up shows how this is now turns into a high level of features, but still sort of spatially related. And then beyond that are the activations of the fully connected layers or the dense layers. And we can see this is now much more diverse in the end. And this converted into an estimate of a particular digits in the end. So let's take a detailed look of the layers of LeNet. It contains 5 layers, which includes 2 convolutional layers and 3 dense layers. Even though there is a pooling layer after each of the convolutional layer, we don't count the pooling layer in total number because we don't need to train any weights parameters for the pooling layers. So we can think the LeNet as consisting of 2 parts. So the first part is convolutional blocks, and the second part is a fully connected layer blocks. So the basic units in the convolutional block are 1 convolutional layer and 1 subsequent average pooling layers. So the convolutional layer block is composed of the repeated stack of 2 basic units. So each convolutional layers use a 5x5 kernel and processes each output with a sigmoid activation function. So the convolutional layer has 6 output channels, and the second convolutional layer increases the channel depth further to 16th. The convolutional layer is used to recognize the spatial patterns in the image, such as the lines and the parts of the objects. And then the subsequent average pooling layers is used to reduce the dimensionalities of the previous layers. And the second part of LeNet is a fully connected layer block. It has 3 fully connected layers with 120, 84, and 10 neurons, respectively. Because we are still performing classification, the 10-dimensional output layer corresponds to the number of possible output classes. So that is LeNet. Even though it was trained on some old-fashioned CPUs, it still made a huge breakthrough back in 1990s. In the next lecture, we will explore some convolutional neural network architectures trained on the modern GPUs.